Here is a reading of section 3.1, Molecular and Formula Masses. Using atomic masses from the periodic table and a molecular formula, we can determine the molecular mass, which is the mass in atomic mass units, the abbreviation is AMU, of an individual molecule. The molecular mass is simply the sum of the atomic masses of the atoms that make up the molecule. We multiply the atomic mass of each element by the number of atoms of that element in the molecule, and then sum the masses for each element present. For example, if we want to find the molecular mass of H2O, what we would do is we would take 2, which is the number of atoms in the water molecule, H2O, multiply that by the atomic mass of hydrogen. We would look that up in the periodic table, so make sure you have a periodic table next to you, plus the atomic mass of oxygen. Now, why the atomic mass of oxygen and not 2 times? Because if you look at the chemical formula, H2O, there's only 1 oxygen atom in that formula, not 2. So this would equal 2 times 1.008 AMU, that's the hydrogen, plus 16.00 AMU, that's the oxygen. And that would equal 18.02 AMU. That would be called the molecular mass of water, H2O, okay? Because the atomic masses on the periodic table are average atomic masses, the result of such a determination is an average molecular mass, sometimes referred to as the molecular weight. That's an old term, by the way, molecular weight. We don't use that term very often anymore, but you will see it sometimes. So, as with the term atomic mass, we will use the term molecular mass in this text. So this issue of average just comes out. That's an issue in chapter 2 regarding the periodic table. The numbers that we're using are average values from the different isotopes that are found in nature, but we'll just use those values in the periodic table. Although an ionic compound does not have a molecular mass, we can use its empirical formula to determine its formula mass, the mass of a formula unit, sometimes called the formula weight. Sample problem 3.1 illustrates how to determine molecular mass and formula mass. So the issue there is that an ionic compound isn't actually comprised of little molecules. It's comprised of a large crystal with huge numbers of ions bound together. So there is no individual molecule to calculate the molecular mass for. But what we do is we just look at the empirical formula. The formula, for example, of sodium chloride's table salt is NaCl. We would just add up those atomic masses to find what's called the formula mass. So if you want to use the term molecular weight instead of molecular mass, that's okay. If you want to use the term formula weight instead of formula mass, that's okay. But the textbook will use the term mass as opposed to weight. Of course, you want to try this sample problem 3.1. That's recorded in a separate video for you to try.